Hi everyone, welcome. I'm a big fan of MIT's open courseware courses, and I was looking at this specific course and I realized that they are just introducing the idea of algorithms using a numerical example, and this algorithm finds the square root of a number. And the algorithm was initially proposed by a first century mathematician, the hero of Alexandria, and published at that time. And it's been there since. And then Newton's method is kind of the same way, trying to find the value after a number of iterations using a tangential approach, using derivatives. And I wanted to try this using Excel, but not just base Excel, but also using the Excel's new feature, which is the lambda function in Excel. So what I'm going to do today or in this video is that I'm going to first use the base Excel to find the square root of a value. So develop this using the formula provided there, and after that I will create a lambda function, a specific function, and for these iterations, and after that I'm going to be using the recursiveness within the lambda function. So which is I think the important contribution of this video is to understand how you can call the function within the function and make that reach to your desired value and within a certain tolerance level. So let's do that. I'm going to try to find the square root of 625, and I'm going to be just making a guess first, and my guess is going to be, let's say I'm dumb enough to think that the square root of 625 is 500. Okay, now what we want to do here is that the first step of the algorithm is grabbing this initial guess, okay, and then we will add the plus the value that we are trying to find the square root of, and we will then divide that value by our initial guess, and we'll divide this whole thing by 2. We'll need to use a $sign on B1. So the reason for that is we are going to copy this down, and then we do not want this to go from the first row. It's going to stay in the first row. And this is it. So initially, for the first iteration, using on my initial guess, my value is 250. But we know that the square root of 625 is not 250, but is going to converge to that value. So for my second iteration, we're going to update the guess. So it is the iterated guess, and then we will keep doing that. So then I'll update my value as well. So 126. And this value is going to be after a certain number of iterations, then it is going to converge to the square root. Like very, very clever method, and even for I think especially for the first century. Okay, so we have now that we just double click on those, and then conversion happened like iteration 6. It was close enough, so 25. So 625, the square root is a 25. Let's say that my initial guess is I'm gonna just maybe making that as 4. Okay, and even that is just finding the value. If I make my initial guess to be 5,000, and it's going to take longer for it to converge, but it is going to converge to the optimal value. Now, instead of just using this formula here, sometimes the formulas are more complicated and you do not want the end users to use formulas, but they just let them use some functions. So what we could do is that we could create a special function for this, just to use 2 inputs to create the output. And the Excel's new feature is the lambda function. So the lambda function allows you to create user-defined functions. In the past, you could only do that using the Excel macros and the VBA, but right now within the Excel environment, so it is very easy for you to create these lambda functions. So under the formulas tab, I'm going to go to name manager, but before that, I want to type this in here in a large text box. And I always tell my students to use a text box when they're commenting on Excel, because you do not want to just put your text on this in the cells. It's nicer to just put them in a text box. So the function is going to look like this. We'll first make that equal to lambda. So the lambda is going to take two inputs, the attributes. The first one is going to be what? The value that we are trying to find the square root of. And then our guess. These are my inputs. Just using these two inputs, then I will just use the algorithm, the function. And the function is that it's going to grab the guess plus the value divided by guess. Okay, then the whole thing is divided by 2. So it's the average of those two. And this is an input. This is the second input. And this part is the output. It's using the two inputs that we have. So you can create any function that you want just using this idea. Okay, so I'm gonna make that, close that parenthesis for the lambda function, copy that function, and I can go to the formulas tab, name manager, a new function, and I am going to now just name this. Let's just name that as the hero square root. Why is it hero square root? Because he was the original designer of this algorithm. Okay, so I'm gonna make that and just put that lambda function there and click OK. If it works, so it's gonna just find me the value. Okay, so I'll have, instead of just using this, so what I'll do is I'm gonna be just making that equal to hero square root, and the value is 625, and the iterated guess is B4. And I'm going to just put for B1, I need to put the $sign, and B4 it's gonna go down. I don't think it's going down, right? So it is essentially a B4, it's gonna, for this function it's going down. And then I will double click on that. As you see here, we are able to create a function, hero square root, and using the value and the guess, and the user knows what these inputs are. You could just enter. It's like any other function in Excel, and you are creating. But we were not able to create the function that the way that we want it to work, right? We do not want to do all the iterations ourselves. We want this function to do the iterations within, and that is also possible. So that's the recursiveness can be done here. That is kind of the neat understanding of this, and you could just maybe create some algorithms, recursive algorithms using the lambda function, which is a plus that you do not need to use any other program. You could do everything in Excel. If you like Excel, I think that is a huge thing for you and for me as well. And I'm going to be now, let's say, finding the square root of, let's say, to maybe 5,625. And where did I come up with this number? I know that my uncle taught me some kind of a trick. If there was, let's say, if there is numbers like 75 times 75, and what you do is that if they have to be the same number, 7 times, then this 7, we're gonna just add one more value. 7 times 8 is 56, and then we are gonna put a 25 after. I mean, it makes sense if you just put these values, but it's a neat idea to fast find the values. For example, let's say I wanna find the value for 45 times 45. So 4 times 5 is 20, it's 2025. So it's kind of an easy way of finding. Anyhow, so let's say my initial guess for this is 3. Okay, that's a very, very, I think, deviated answer for it, but we're gonna keep it there. And I wanna be close to whatever the actual square root is. If I'm almost like close to that number, I'm okay with it. So that's my tolerance level. So this function is going to require 3 inputs, and it's going to calculate the output by just doing iterations within. So I'll insert another text box here, and then I am going to just start typing my lambda function. The lambda function is going to require the value, and then it's going to require the guess. It's going to require the tolerance now. So there are 3 inputs. And then we're going to put the function. So the function is going to just first look for if, okay? So if whatever the guess is, sometimes we may make the best guess and then we may find the number, right? If the guess squared, so because that's the square root of the value that we are trying to find, right? And that is if we are going to square the guess, and if that has to be equal to this value, and almost or maybe very close to that value. So guess squared minus the value. If that difference is less than or equal to the tolerance level, then the result is guess. But the issue is that if the guess is a small number, then the result is going to be negative, and then we are not going to be able to find the correct answer. So we have to take the absolute value of this difference. Okay, so if the absolute value of this difference is less than or equal to tolerance, then the result is the guess. Otherwise, if function works in this way, so it makes a logical statement. If this logical statement is true, the result is going to be this value. If not, then the result is going to call the function again. Now at this time, we need to know what name that we want to assign the lambda function. So here, because I'm using the recursiveness here, I'm going to call that R hero square root. So recursive, it doesn't matter what you call, but it is going to be just something that I decided right now. So R hero square root is going to be called again. And this time, it's going to use the value because we're trying to find the square root of this number. But we're not going to use the guess here. We will update the guess, and the updated guess is going to be guess plus value divided by guess and divided by 2. Okay, and then we will just still use the tolerance, and then we'll close this R hero square root function. Then we will close the if statement parentheses. Then we will close the lambda parentheses. And now if this works, you're gonna like this video and subscribe if you have watched so far. But this is, I think it's kind of a nice feature of Excel. So I'm gonna copy that. I need to make sure that I'm gonna be using the same name to the function because the function is gonna call itself. So we'll go to formulas, the name manager, new function, R hero square root, and now this is going to be that value. Okay, if I have not made any mistake, it should work, and I'm hoping that I did not make any mistake there. So the square root is going to be R hero square root, and value is this, guess is this, and the tolerance is this, and enter. So 75, and we are able to find the square root up to that tolerance level. So if I increase my tolerance level, and I'm able to find the exact number 75, so I can just enter any number. Oops, maybe my initial guess is going to be like it's very small. Let's say here 6,000. Let's see here if the algorithm is, yes, the algorithm requires some kind of, because if the value is not converging, it's not going to be able to find that value within that specific tolerance level. And here, I think the initial guess did not matter. The tolerance level mattered. So I'm going to make this, yeah. So initial guess is okay. The tolerance, if you make it like very, very accurate, it's not going to be able to find for certain square roots where the square root is not an integer number. And that is the end of my presentation, and thanks for watching.